Good evening. My name is Payal. I am a database administrator for a company called OmniTI. We are mainly a web consulting firm, and on the database side of things, we consult with open source databases. And mainly right now, I've been focusing on Postgres. That's my email handle. Feel free to give me any sort of feedback you have on this talk, good or bad. I promise you I'll try to handle it as best as I can. So since the talk is about essential Postgres tuning, I just want to make something clear. This is a topic that's often talked about in every Postgres meetup or conference you would go to. And there's usually either a 3-hour tutorial talk or a Linux tuning tutorial talk. So it's hard to condense this tuning thing and talk about everything that involves tuning in a 1-hour talk. But there's a reason I wanted to do this is because a lot of the people, especially newcomers in Postgres that I talk to, they often get lost in the various parameters that exist in Postgres. So Postgres 10, can anybody tell me except Jonathan, because you would know, how many parameters to tune there are in Postgres 10?
340.
What's that?
340.
Oh, that's really high. Okay, yeah, no, it's lower than that. It's 270, so we're getting there. I think we added like 13 parameters between 9.6 and 10. So we are growing our configuration at an exponential speed. But yeah, so the warning, the caveat with this talk is this is essential performance tuning. There are things like vacuuming in Postgres or logging where there is still a lot of potential for performance tuning. Like obviously if you're going to log everything, your performance might suffer. If your vacuum settings are off, again, you might suffer. But I'm not going to cover all of those things. I am going to mainly talk about the things that I most often find myself touching when I'm setting up a client's database or migrating a database or upgrading to a new version. So there's 2 levels to Postgres performance tuning. The first one is obviously Postgres, and the second one is the Linux kernel. Now it's not just the Linux kernel, it's any operating system that you're running it on, but I'm mainly going to talk about Linux because number 1, that's what I've been working on lately, and number 2, there are a lot of parallels between Linux and other operating systems, Windows not included. So if you're using BSD, chances are you have something that probably has a different name but is tuned and works in almost a similar way. So we are going to look at both these levels, but first we're going to start with Postgres. Anybody who's used Postgres has probably touched one of the GUCs, which is the closest thing to a global variable in Postgres. This is an excerpt taken out from a mailing thread, which describes GUCs perfectly. It's basically global variables that you can set either at the cluster level, the database level, the session level, the user level, or if you like to call it role, at the role level. And there are 270 GUCs in Postgres 10, but I'm only going to talk about the top 7 or 8 that I think are essential to Postgres performance that you should be focusing on. And the first one is max connections. By itself, max connections seems like something that probably doesn't have to do with performance all that much. If you have the number of resources, you set up your connections to whichever value you see fit. But it actually matters a lot, especially as a supportive variable for other performance variables, in the sense that Postgres is process-based, it's not thread-based. So the number of connections that are active at any time are going to use up the total resources that your system has. So after a point, there's a knee in the graph wherein after X connections, X active connections at the same time, any more and your performances, your throughput is going to suffer, your latency is going to increase. And to determine that amount, you basically just have to start low. And if you feel like you really need to up the connections, go up. But Do keep in mind, so this is, there is no such formula for SSDs, but for HDDs, this is the rough formula that you could use to determine how many max connections you can have. Do keep in mind that this is not the number of connections you should set it to. If it can be lower, please set it lower. Your database is going to be happy. And also keep in mind that these, what we're talking about, are active connections. Connections can have various statuses in Postgres. So there's something called idle, which is basically it's just sitting idle. There's something called idle in transaction, waiting for I/O. Those connections don't count when it comes to how much resources are getting utilized. It's only the actively running connections that count.
So I have a question. What if I have an application that has, I have a distributed application, and they're all making lots and lots of connections? What can I do to help mitigate?
Yes, that's a great point. So if you feel like after a point you can't really keep your connections low, you really ought to have more connections. There's pooling. And so you can, the most popular tool is PG Bouncer. There's also PG Pool. You could look them up in the Postgres wiki. I believe they have their own dedicated pages. So if you really feel like the number of connections that you have are not enough, you really need more, you use these pooling tools. What they essentially do is they queue up the connections. So they won't let all those active connections go to the Postgres straight away. They will make some of the connections queue up. They will make them wait. And contrary to what you might think, that if there are 1,000 connections and they are all running at the same time in Postgres, that will be faster if your machine can run them, as opposed to 500 connections running at the same time and 100 waiting. It so happens people have done benchmarks to suggest that queuing does not delay that entire process any more than running them at the same time will. So it is better for your system, it is better for your database to enable queuing if at all you feel like after a certain point you do have to have more connections. Yes?
I remember buying many years ago a SQL pooling driver for a Windows platform, and the difference was dramatic, in terms of like, if you have that. I don't know if there's equivalents for Postgres.
I don't think, is there a hardware tool?
Not that I know.
Yeah, the most common one is PG Bouncer. The second most popular one is PG Pool, but PG Pool isn't just a pooling tool. It is much more like it provides availability for high availability, automated failovers, and other stuff around it. And so basically, if you just want pooling, you would go with PG Bouncer. I think that's the closest equivalent that I can think of. Yeah, so going on to shared buffers, probably one of the most important things and one of the main things you're going to set if you're tuning your Postgres cluster, it's basically a data cache. It's going to cache in all the data pages that you need. In Linux, in Postgres versions pre-9.4, Postgres didn't actually talk to the kernel and get those values that you see there, which is max, min, and all. So if you were running, I hope you're not, but if you were running an older version of Postgres, you would have to set, it is possible you will have to alter one of those values or more. Now max and min are basically determining the size of your page, while all is basically telling you, why would you use all is if you're running multiple clusters on the same machine. So that's the only time that you will have to change all. Recommendation, yes.
Why we need to change the SH more?
So exactly, I cannot remember off the top of my head, but if you're running multiple clusters on the same machine, there's, yeah, I will have to look that up. I'm sorry, yeah.
Okay.
I don't want to give you what I think it is, but I don't want to give you the wrong
I think
information.
we're running multiple instances on a single machine, so I want to know.
What version are you running?
9.6.
Yeah, you don't have to worry about that. Okay. Yeah, this is only for pre-9.4. Oftentimes, if you ran pre-9, yes.
Does 9 onwards actually make the modifications itself, or?
I think I'm not sure how exactly it deals with that, but I'm sure it does, because otherwise it would also fail like the pre-versions where if your max was too small, then the shared buffers that you were setting, it's going to fail to start up and say, hey, you need to increase this setting. 9.4 onwards, that doesn't happen. So my guess is the same as yours, that it has found a way to automatically change those and talk to the kernel.
How exactly is shared memory being used in Postgres?
It is mainly used as a page cache. So all the data that needs to be read in or written out. So everything that Postgres needs to touch is coming into your shared buffers. And things that are not.
But what are the processes that are sharing that memory?
Only Postgres.
Yeah,
so
but
any
there
process.
has to be more than one process if
Yes.
it's a shared memory region.
Well, Postgres is process-based, so every connection that's happening in Postgres is a process of its own.
Oh, it's a separate process.
Yes, Postgres is not thread-based.
Okay.
So every connection that you're making in Postgres is a process, and so all of those Postgres processes are sharing that buffer. Yes.
Is that gonna be true for 11? You just said Postgres is process-based process, not thread. So
Yes.
11, they're implementing full parallelization, right?
But
Just a question.
probably, so there are better people to talk about that specifically, but the essential nature of Postgres not being thread-based won't change. So parallelization, the way it's implemented, 9.4 onwards on a basic level, is you can choose to do it, but by default it is off. So even if you choose to do it, it is going to parallelize one process, but the connections at the core level, any new connection isn't going to be a separate thread. So any new connection is still, even in 11, going to be a process of its own. Now within that, it can spawn threads, but yeah. Recommendation for shared buffers, there's the usual recommendation is set it to 25% of your RAM as long as you have a RAM that's greater than a gig. Or set it to 1/3 or set it to 2/3. So if you Google this, you will find a very varied set of opinions on this. Yes.
At the last PG Conf in New York, somebody had said that the new thinking was that 1/4 is now the maximum recommended. Is that
I think that's wrong.
okay?
I'm going to discuss why. I might be wrong.
What is this 1/4? 1/4?
Oh, 1/4 of the RAM.
Oh, okay.
So what the value to set for shared buffers should be 1/4 of the RAM at max. That maybe that person said that at maximum it should be that, or it should be lower. But if they said it shouldn't be higher, I wouldn't agree with that, because lately, as your amount of RAM is increasing, your machines are getting better. There have been cases, and quite a few cases, where setting half the memory or 40% of the RAM as shared buffers has resulted in performance gain. People have benchmarks up on Google. You can feel free to look it up. But still, the conventional wisdom remains that set it to 25%. If your database is too busy, or if you're too paranoid, and if you have too much RAM, set it to 1/3. Yes.
What's the shipping default when you
Um,
install it?
It's very
depends
conservative.
on
Pathetically
what-
low.
It's like 128 megabytes, and that was a fight to get it up to that high. It's very conservative.
You had a question?
I did have a question. Did you talk about the 8 gigabyte inflection point?
No.
Or that's still a thing? All right, so is the 8 gigabyte inflection point still a thing, where if you set it above 8 gigabytes,
Oh,
bad
yes.
things could happen?
Yes. But again, I don't think that's conventional wisdom, yes. But I don't think that's true in practice anymore.
I think, because I think there were improvements made to the kernel that mooted that.
Yes.
Yeah, I remember.
Yeah.
I was running a system with 12 gigabytes, and it was fine.
Yeah, I have systems, extremely large data warehouses where I have much more than 8, and there's a reason for having it that high. However, even though it goes, yes,
No, you can continue on this. because
even
I-
though it goes against conventional wisdom to set it high, and many people in talks, conferences are going to tell you never to set it beyond a certain percentage of the RAM or beyond a certain hard limit, in spite of the performance that you might gain from a very high shared buffer setting, you should take into account how much total available RAM you have. So even if you're setting it too high, and Postgres is performing better, right? But the amount of memory that's left out, so you set 40% of the RAM to shared buffers and 60% is left out, but turns out shared buffers only caches in the pages, the data pages, not the operations that happen on your queries, right? So any sorting, any hashing, any vacuuming, work mem related stuff, it all happens outside of the shared buffer. Shared buffer is basically your data page cache. So if you don't have available RAM aside from your shared buffers, if you don't have enough of that for your actual query operations, then your database is going to be slow. So unless you have a very high amount of RAM, stick with conventional wisdom of 25 to 30% maximum. Another reason for sticking with a lower limit is if you're running it on a 32-bit system, there is a hard limit of 2 to 2.5 gigabytes. And that has something to do with address space and 32-bit running out of address space.
What's a 32-bit system, Joe?
I wish that was true.
Well, sometimes you have it like specialized firmware or something like that. You're running on a busy box or something.
Mm-hmm. You can have an extremely large shared buffers where you have extremely large RAM, but if your I/O throughput is limited, then your database is going to be slower than what it would be with a smaller shared buffer. And the reason for that would be the larger shared buffers you have, the larger is the amount of data that Postgres will have to write to disk at checkpoint time. And so obviously, if you're writing too much, that might cause latency spikes. So again, another reason to stick with conventional wisdom of 25 to 30%. But in spite of all this, there are cases, especially on newer machines, where you will see a benefit of having a higher than recommended shared buffers value. And how can you find that out? There's a core extension called PG Buffer Cache. So if you install Postgres with Contrib, you will have this by default. All you have to do is create extension. Anybody used this before? Okay, so this is a great tool to determine exactly how many shared buffers you would need. Basically, Postgres follows an algorithm called clock sweep algorithm. Any usual cache where any hit will increase the counter of that page by 1 and 1 and 1, and so you have a popularity ranking of all the pages. And so 5 being the most popular, 1 being the least. And so PG Buffer Cache can actually track which page has which popularity rating. So you can actually query PG Buffer Cache to tell you how much of your shared buffer is being occupied by what class of popular pages. So all the pages that are extremely popular are taking up 90% of your shared buffers. That's great. But anything that has a popularity of 3, 4, or 5 that is reasonably popular, they're taking up all of your shared buffers. So that likely means that your shared buffers is really low, because if it's already consuming all of your shared buffers, there might be more popular pages that might fit in your shared buffers. So if you can afford to, you might want to up your shared buffers. Now, one thing, shared buffers is a hard allocation of memory that is set whenever Postgres is started. So of course, it requires a restart, so you set it once. It's not something you can tune on in the air, so keep that in mind. But yeah, PG Buffer Cache is an excellent tool for it. One slight note on that is every time you query PG Buffer Cache, it takes a lock on your shared buffers. Not a huge deal, but just don't run it in production during the highest load time. And close to shared buffers, and perhaps even more important in certain cases, is effective cache size, which is the total RAM available to Postgres. So in most cases, you have a dedicated server for Postgres, right? And so this value basically will involve your shared buffers plus the free memory. So you can just do a top on your system and get an idea of how much RAM you should allot to it. 1/2 to 3/4 is the conventional recommendation. But you can, even if it's a dedicated system and you know that your database is going to be busy, it's prod, setting it to 90% is not unheard of. It is, unlike shared buffers, which is a hard allocation of memory that Postgres will acquire at start time, this is just basically an estimate. So you're just telling Postgres, this is how much you have available at your service, and it's possible that Postgres is not actually able to use that, but that's not relevant for this setting. So this is just to tell the Postgres planner, hey, use this index, or hey, use this slightly better thing that you're going to use, as opposed to doing a conventional or a boring sequential scan or a heap join. So yeah, it's just an estimation. Max connections should be taken into account when you're doing this. So if you have too many connections, remember I mentioned that max connections does affect the other performance parameters. So this is one of those that it really affects. If you have more connections, you have more Postgres processes. If you have more Postgres processes, depending on how complex each of those processes are, it's possible for you to really be short on RAM. So you want to take into account what your max connection is set to before you set your effective cache size.
Wait, sorry, so
Yes.
for the effective cache size, so like how do you calculate how much to put in then? If you take max connections plus shared buffers, then
There's no hard-coded formula for that. What I would do, I would start with is I would see what total amount of RAM I have and set it to at least 80%. And that's assuming I'm running it on a dedicated server.
wait, but 80%, but what if you what if you put your shared buffers to 2/3 of the then?
Yeah, 80% is assuming my shared buffer is following the 25 to 30%
Okay.
limit. Yes. If you're setting your shared buffers higher than that, so if you're setting it to 40%, that's a territory where you cannot follow the conventional recommendation then. You have to first take into account that aside from that data page cache, how complex are your queries going to be? How many total connections are you going to have? So do you still, the 60% of RAM, aside from shared buffers, is it still enough to handle that load of sorting, of performing other operations, of maintenance operations? Is it still enough? If it is, then you still can go ahead and set it to 80%. And also remember that this does include the amount that you set for your shared buffers. So include the shared buffers when you're setting effective cache size.
And are there any conventions about max connections, like an arbitrary number that's like kind of the general?
Yes, the recommendation is set it to as low as you need it to be. Don't set it to don't start with connections of 300 if you know that at any point your app will only make 100 connections. Start with 110 or 150 and then go from there. So keep it as low as you can.
What's the shipping default on that one?
What's that?
What's the shipping default on max connections roughly?
It's 10.
Oh.
It's 10. So it's fairly low. Yeah, you're going to, if you're using it in production, you're going to have to change it. Next up is work memory. Quite tricky. People have been bitten by it, but I hope by now it's well known that work mem is, first of all, it's the RAM that is used for sorting and hashing. So merge joins or hash joins and any other operations like those, order by, distinct. All of those operations are going to be using your work memory. The key thing to remember, again, max connections has a role to play. Why? Because work memory is per session and per user and per query. So it can be set on various levels. So you can set it in the cluster at start time. Then you can change it while the cluster is running. Then you can change it when a particular role is running something. You can also change it per session. And why should you do that? It's because work memory is per query. So the default for work mem is 4 MB, and that means that if one of my query has 10 sorting operations, let's say, each of those sorting operations can acquire 4 MB of memory. So if I have 100 connections, each with 10 sorting operations, multiply that, and that will be your actual memory getting used at any point in time. And that's why people usually see, oh, work mem is the mem that query can use for its operations. Let me set it to as high as I can. What they don't take into account is that it's per operation per query. So it can exponentially increase in a scary fashion, and out of memory errors are not unheard of if your work mem is too high. One thing to note though is, and this is not something that's mentioned mainly because people do tend to set it high. If you're running a reporting database, you might want to set it a little bit higher if you have a lower number of connections, relatively speaking. So if you only have 10 active connections at any time in your reporting database, and each of the connections is going to be fairly heavy, right? It's an analytical database. So you want to set up a higher work mem depending on how much RAM you have, so that your performance is better overall. Random page cost. It's too high. They're not changing the default, and the reason for that is because HDDs are still around, magnetic drives, and yeah, that's basically it. But for any practical purposes, even if you don't have SSDs, you might still want to lower it. You definitely want to lower this. This is one parameter. If you're benchmarking, obviously you will be benchmarking before you tune your production. You will see that changing it from 4 to 2 leads to a significant performance difference overall. I'm talking about thousands of TPS more than what it was on 4. And you can set it to 2 even if you don't have all SSDs, because this value is relative to sequential page cost, which is 1 by default. So it is basically, the reason it is 4 is so that to tell Postgres that a random scan, like an index fetch, is going to be 40 times, 4 into 10 times more costly than a sequential scan. In practice, it's going to be costlier if it is HDDs, but Postgres assumes that some of that information, some of that data pages are already in your RAM, so it's not actually, yes?
So that slide should really say that the default of 4 is too damn high for SSDs.
I'm not so sure. It is still, so because of the optimizations that have happened over the years in major Postgres versions, there are a lot of different types of index scans available. And so I would certainly say that even if you're using HDDs and you have an adequate amount of RAM, not like 10 years ago.
So SSDs or large
yes.
RAM.
Basically, in practice today, either you have a large RAM or you have SSDs. Yes.
And that's settable per table space?
You can change it per table space, but basically you can change it at the cluster level as well.
Okay.
Yes.
So, but you could, if you knew
Yes.
you had some slow disk, you could set it back to 4
Exactly.
for that.
Yes,
Okay.
you can.
So if
Yes.
it's all SSDs, why not just set it to 1 then?
So good question. I have had heated arguments with my colleagues over that because I just go by the numbers I see in benchmarks, and setting it to 1, which is what I do, leads to a performance difference in a positive
It goes
way.
index happy.
Yes,
Really?
yes. And in SSDs, there is no additional seek time, so it makes sense to set it to 1. However, paranoid people say that it depends on the quality of the SSD, where a sequential scan might still be somehow better than accessing several thousand pages randomly.
What if you have a server that's a hybrid of like SSDs and HDDs, but you put the indexes on a table space that's specifically set to the actual SSDs? Then how would you?
As long as your index and the rows that your index is pointing to is on SSDs, I would say just go ahead with that.
Right, but then the random page cost, so you should then set it per
Yeah.
table space level at that
Yes,
point? Okay.
yes, that's basically, yeah. So if you have an HDD and an SSD and you have planned it well, different table spaces, definitely do that. One thing to keep in mind is this is not an integer value only, it accepts decimals. So even if you're in that paranoid group that, oh, SSDs can still be slower than index scans can still be slower, you can always set it to 1.2 or 1.1 or 1.5. You don't exactly have to either do it 1 or 2. You can set it in the middle. So that's something to keep in mind.
On 32 core AWS boxes.
Checkpointing is related to a lot of things in Postgres, but strictly speaking, from an essential performance point of view, there's 3 parameters you need to focus on. By default, your checkpoint segments has a value of 3, which basically means by default it's going to have 3 wall files. Each wall file is 16 MB. So that's 48 MB. What it means is after every 48 MB of writes of wall files worth, it's going to write to disk. If you have a very heavy production, that's going to be a lot of disk access that you probably can do without. So you definitely want to increase that checkpoint segment to a higher value. How high depends on your individual resources, on your disk space as well, because obviously if you increase that, those more number of files are going to be on your disk. Another thing to keep in mind is, for those of you that are extremely paranoid, the larger volume of wall files that you have that are not written to disk, it means the longer it will take Postgres to recover in case of a crash. So that is something to keep in mind as well, but still, checkpoint segment default value of 3 is way too low. Your production is going to suffer immensely if you keep it that way. So please increase it. Completion target, it's got a complex type definition in the documentation. What it is basically saying, once you have a significant amount of segments, that is a good amount of wall files to be written to disk, right? You can span out the writes. You don't have to write it all at once. You can spread out your writes based on how long it takes for the next checkpoint time to arrive. So by default, this completion target is 50%, which basically means by the time the next checkpoint, the next wall file is 50% written, complete all of these wall writes to disk. So the maximum you can have is 0.9, and you want to increase it to that, assuming that you've also increased the checkpoint segment. The only reason the default is still 0.5 is because the checkpoint segments is still 3, and so if you have a low checkpoint segment, even if your completion target is 90% of the next checkpoint, it's really not that much time. So nothing is to be gained from that. So I'm assuming that Postgres, if it ever changes the defaults, it will change both of these defaults at the same time or neither. So you definitely want to increase these two. Also note that the default checkpoint timeout is 5 minutes. So regardless of those 2 values, every 5 minutes your database is going to write to disk. And so you probably want to increase that too. Yeah. Don't increase it too much, because then obviously you're running into disaster recovery, longer disaster recovery times. But yeah, several minutes, definitely higher than 5 should be recommended. Again, something extremely specific in certain cases. Postgres does not have query planning hints, right? And so that makes this all the more important. What is the default stats target? It is basically collecting statistics at regular intervals of each of the tables. So what kind of data does it have? How long will it take to do a sequence scan? How long will it take to do an index scan? And stats like those. It's a sample of the table data, basically. So depends on the sample size of each of those tables. Usually, I think by default, this is set to 10. So it will, in every table, it's going to take in 10 random rows as a sample and then use that to analyze and make its query plan stats. So better plan versus longer analyze time. If you have a significantly varied column or data in your table, you want to have a higher stats target, because 10 rows are probably not going to represent your 1 million worth of rows Yes.
And that's the 10 most common values found?
I'm not sure. I think it's just random. So this is different. This sampling is different from the table sample option that Postgres provides the user with, which has that
Oh, okay.
option.
Sorry, I
Yeah.
had those confused.
So yeah, table sample is a user accessible sampling method where you have Bernoulli's theorem and you have the random and you have the popularity. But this is something that happens internally in Postgres. I'm not sure what algorithm, but I would bet it is just basic random at random. That I'm so sure because oftentimes even in cases where the data is largely varied, it seldom would represent the data as a whole. So it's still going to take stuff at random and not represent a pattern, or not going to tell you that, hey, you might want to have a higher.
So this is different than if I look in the data dictionary for that index, and it gives me like a set of the most common values.
No,
Okay,
that's the same thing.
It is?
Yeah,
Okay.
yeah, that will be the same thing. What it is different is there is so if you want to manually sample data from a table, you will use something called table sample function in Postgres. This is not that. So this doesn't use that function that is user accessible. So this happens internally at random. Does that answer your question?
Yeah,
Okay.
I'll tell you that later. Thanks.
Okay.
So if it's done internally, to what ends is it used for? Like what larger?
Oh, yes, I was coming to that. Okay, actually, I will have to explain it without the pointer in there. It is used for query planning. So when you do a select star from users where manager equals X, Postgres planner is the one that decides whether X, even if there's an index on X, it should use the index or just sequence scan. And the way it decides that is by this process, putting in the sample and the statistics for that. So that it's used for query planning. And because Postgres does not allow for explicit query hints, this is all the more important. So if you ever run into a situation, which you someday will if you haven't already, you're going to see that something should use an index and it's just not using it. And what you want to do, one of the things, if you don't want to investigate it further, just you can increase the statistic target per table and you can increase it per column. So for that particular column, just try increasing it to 1,000 or 100. And then reanalyze the table and run your explain plan again, and I won't be surprised if it starts using the index then. So that happens in cases where that particular problem column is actually very varied, and Postgres doesn't know that because it's only getting the default 10 rows, and it just thinks that it's just the usual. Closely related to the previous parameter is the stats temp directory. It's where a file resides in this directory basically that gathers, that stores in all the statistics that the previous parameter makes Postgres collect. It contains the latest statistics, and it is a good idea. By default, it lies in your PG data location, but it is a good idea to place it on RAM. So all you have to do is change the path. And why? Because if it's in RAM, every time Query Planner is being used, it doesn't have to go to disk to ask, hey, what's the stats on this table? What should I use? So it's much faster that way. One thing to note is just because it's in RAM doesn't mean it's definitely going to be volatile across restarts. If your Postgres is properly shut down, before it shuts down, it's going to write to disk, write this file to disk. If it is crashing, then it's not going to write to disk. So if you're recovering from a crash, it's a good idea to just analyze your database. Analyze often happens with vacuum, but by itself, it can be done as well, and it's quite fast, so it won't take you hours to analyze your database. This is one of the parameters that is actually not so popular in performance tuning, and that's why I wanted to cover it, because often you would just look at it in the Postgres config and just ignore it. What it's used for is for complex functions, especially recursion. It depends on what the stack depth size of your kernel is, which you can find out with the ulimit function. And the recommendation is keep it a few bits below what the actual limit is. And if you set it to higher than the actual limit, which is not allowed in the latest Postgres versions, but if you have an old version and you set it that high, your Postgres is going to crash if a recursive function, say an infinite loop, just keeps.
Or an aggregate, I guess.
Yes, that too. So be very careful when increasing that, but the default is, again, given the latest machines and most people, the way they run the resources they have, the default of 2 MB is quite conservative. So check your stack depth size, and usually, even if you're paranoid, set it to at least 4. So that way it's at least better than the default. I/O concurrency is basically how many spindles do you have for your I/O activity. Basically parallel access to your disk. For SSD, so the available value is 1 to 1000. By default it is 1, so you definitely want to increase it. If you're running a RAID type specification, then it depends on what, so it depends on a number of factors, and you're better off, instead of me trying to explain it, you're better off reading it off the wiki, but there's good information in the wiki if you have a RAID type specification. If you're running it on SSDs, you can easily set it to 100 or even more, up until 1000. The thing with this, though, I have noticed is beyond a certain point, I haven't seen a performance gain. Now, there can be 2 reasons for that. Number one, personally, I haven't, so I see a better throughput when I increase it from its default of 1 to 10. But when I go further, I set it to 100 or 500, I don't see a performance gain. I don't see a decline either, but I don't see a gain. So the one thing is, maybe the scripts that I'm using for benchmarking, the queries that I'm using are not something that this might be used for. Postgres doesn't see it as beneficial. The second thing is, this is only used for bitmap heap scans right now. This might change, it might be used for other operations, but right now it's only used for the bitmap heap scan. If you're writing to disk, you can either turn full page writes off and fsync off, so that's going to increase your database performance, right? Obviously. It's not going to wait until it's sure your data has been written, but at what cost do you want your performance to increase? So don't do that unless you believe in the YOLO philosophy. Have it set to on. Fsync is on by default. Another thing to keep in mind is there is a parameter called wall sync method, and it's only used if your fsync is by default on. So in that case, your wall sync method, by default, it points to f data sync on Linux, which is basically fsync, I want to say. One thing that you might want to go back and check in your prod systems is what Linux kernel your production is on, because there was a pretty significant bug with fsync, how Linux handles fsync and how Postgres thinks Linux handles fsync, that recently was patched 4.4 onwards. So kernel version 4.4 is what I mean. So you might want to upgrade that. The latest kernel minor versions have that patched in there. It was basically a problem with fsync returning an error. If there was a problem, fsync would return an error to Postgres once, but if there was a problem again, fsync wouldn't do anything. It wouldn't go back and tell Postgres, hey, we're still having trouble. And then Postgres would assume that if fsync hasn't talked back about the failure, it's gone through the second time. So that was a significant bug that's now being patched.
There's still a couple things that are being patched in Postgres around that.
Yes,
So,
it's been patched in kernel, but not in Postgres.
Yeah, I think there's, I might be wrong, I think some fixes are in, there's some more coming in the next release, and then there's some which are just, they're thinking about.
Yeah, okay. So at least the kernel end, you might want to upgrade to the latest version. Postgres. The first thing I want to talk about is out of memory. The way Linux handles it is it behaves like a serial killer. If it runs out of memory, it doesn't care what it's killing. It will just kill it based on certain restrictions, but those aren't set by default. So two things you definitely want to do on your dedicated database system is set these two kernel parameters to disabled and 0. It's fairly obvious what it's telling the kernel to do is basically don't panic if you run out of memory, and do not kill any task, any process if you run out of memory. Let me handle it, let the user handle it. And if you don't want to do those two things, you believe in the kernel and the ability to kill processes, you can exclude your Postgres process by giving Postgres a priority of -17. I'm not sure if priority is the right word, but giving it -17 is a number that Linux kernel will, if it sees it associated with a process, it's going to exclude it from its killing spree.
And that's just renice or?
Not sure.
Okay.
Yeah.
Probably,
What's that?
probably, I think.
Yeah. So, and then scheduler. So CFQ is the latest one. It stands for completely fair queuing. What it is basically a very smart scheduler that handles priorities, that handles what should be given preference when you're writing out to disk or reading from it. It is not that to let it remain as the primary, as the scheduler for your Linux kernel when running Postgres, but the two other older, more conservative schedulers are not bad options. In fact, I would definitely recommend one of those two. Mainly because the way CFQ functions, it's quite complex. So if you run into an issue where you see that the scheduler is the reason that your performance is suffering, you really can't tell what CFQ is actually doing. A lot of it is the way it's designed, it's complex. It works well for certain processes, not for databases. Noop is your friend, first in, first out. If you don't know what your database is going to be like, if you're not sure, if you haven't worked with schedulers, just make sure it's set to Noop. Deadline is basically for read-intensive databases. So if you have way more reads than writes, deadline scheduler is going to prioritize reads over writes. So it's going to make sure that every read that's being requested is processed immediately, while it's going to give writes a lower priority in the sense that it's going to accumulate a certain number of writes before processing it to disk. So yeah, deadline is good for read-only or read-heavy systems. Huge pages is a controversial setting. Mainly because some people say it should be there, some people say just turn it off as soon as you decide to set something as your database server. What huge pages is basically, instead of having to keep every address point, address location in memory, it will point to one of those locations and make a virtual page that's larger than your actual disk page size. So what size your kernel has as a huge page is the last two lines of that code. You can query meminfo for that. And then what should you set huge pages to? You find out by finding, first of all, the postmaster, the main Postgres process that's running on the system. You query its prop status. You see what the VM peak value is, which is basically how much memory it is using, and you divide that with the kernel huge page size setting. So in this case, it's going to come to like 3,100 something. So that's what you can set your nr_huge pages to. One thing to keep in mind is if you set huge pages to something that's lower than what Postgres needs or Postgres wants to use, Postgres will fail to start. So you want to set it very carefully. But 9.4 onwards, there's an option in Postgres config parameter that lets you set whether or not you want to use pages, use huge pages, and the default value for that is try. So that's great because now Postgres would no longer fail. Even if the value in the kernel that you've set is too low, Postgres is going to try to use it. If it can't, it's going to go back to not using huge page. If you're using BSD, there is something very similar to this. It's called super pages. The concept is almost the same. One issue that people complain about and will tell you to stay clear of huge pages is a defragmentation issue which existed in older Linux kernel versions. It's been patched to an extent now, enough that I haven't seen issues with it, but I cannot guarantee that you're not going to run into what happens is that due to the way the kernel defragments your total data pages, it basically breaks down the Postgres buffer blocks in a way that Postgres is unable to deal with the all the blocks of data that it wants to at one time. So Postgres is going to hang. It's going to stop a lot. It's going to have a lot of latency spikes. And if you're suffering through that and you're on an older kernel, definitely try checking if your huge pages is on or off and set it to off. And people have seen a huge improvement just by doing that. Now this is a very interesting section that I want to talk about because I was bitten by it. Now, on most kernels, your overcommit memory, which is a parameter for your virtual memory management in Linux, is by default 0. 0 would mean that you're letting the Linux kernel decide how much memory to overcommit, how much, let it decide on the basis of how much memory it has at any time, how much free memory it has. If you're setting it to 1, it means that always overcommit. You don't want Linux to heuristically decide whether or not it's good to overcommit. You just want to tell Linux, just give it what every process asks. That's useful when you have sparse arrays and for scientific computations where you really don't care about out-of-memory errors as much as you care about just high performance. Don't set it to 1 for databases though. For databases, the appropriate value, the recommended value is 2, which disables overcommit altogether. If you're running your database on a dedicated system, you do not want it to overcommit because that's the main, Postgres is the main process that's running. Why do you want to chance any other process running in your server and just taking up or asking for more memory? So just disable it. That's what you will end up doing. But if you're setting this to 2 and just if you're looking to do this, these are the 2 ways. On the newer kernel versions, you can just use the sysctl command. On the older ones, just use echo. But if you're setting it to 2, which you should for a production database dedicated server, do look at the overcommit ratio. And this is what I got bitten by. Basically, if you have your overcommit memory set to 2, it is very likely you're only using half of your RAM. Your database is only using half of your RAM. That's just as bad as it sounds. This is because the default for overcommit ratio is 50% of the total RAM. And that is because the default for overcommit memory is 1, which is it can overcommit. Linux is allowed to overcommit. But when you disable overcommitting memory, and let the ratio be 50% of the total RAM, guess what? It's only going to use 50% of the total RAM. And so I got bitten by it because I was migrating a database server and the new box had lower RAM than the old one and basically resulted in out-of-memory errors. I debugged and first tried to reduce the work memory because I thought maybe newer queries are running in there, but eventually it wasn't the work memory at all. It was just the fact that it was only using 50% of the RAM, and the RAM on the newer machine was much lower than what it was on the older one. And so, yeah, it wasn't enough. And my one complaint point from Postgres documentation is that in its kernel tuning page, doc, it does mention overcommit ratio, but in the context that if you're changing overcommit memory, you might want to look at the overcommit ratio. I don't think that does justice to exactly how important this parameter is, especially given that how many places and how many Postgres people would tell you to disable your overcommit memory, but this aspect is really not well known at all. And I've talked to people at previous conferences, and I was surprised that this is just not well known. So definitely, if you have disabled overcommit memory, or you know that your DBA has, definitely tell your DBA to check this. Finally, there's swappiness. Again, what to keep in RAM, what to transfer to disk. The values can be 1 to 100. Think of it as a percent. I think the default is 40%, yeah. If you have a larger RAM, which these days most people do, you want to lower this for your database. So because you already have available RAM, you don't want your kernel to swap too much unnecessarily. I think that if you have a good enough RAM for your production, just set it to 0, or if you're too paranoid, set it to 10, no more than that. Make sure in your file system, whichever file system you're using, the 2 file system parameters, no A time and no dir A time, are set. What that does is basically Postgres, the way PG data is structurally set up is that each table in your database is a file in the file system. And every time you touch a table, that file gets accessed. What A time does is records the last access of every table. So you can imagine in a busy system, the operating system will spend way too much energy trying to update that last access for each table. So you don't want that to happen. No dir A time is basically for directories, especially when you're only perusing the directories and not actually opening any file in them. So you want both these parameters set, or rather A time disabled in your file system.
So you'd want that in a PG data folder, right?
Yes, whichever disk your PG data resides on. Make sure that's set. And that alone leads to a significant performance improvement in a busy system. One tidbit is oftentimes you want to upgrade your Linux kernel, but your Postgres package is also going to get upgraded. So there are ways, both in CentOS and in Ubuntu, and this is Ubuntu, to pin your package or to freeze package in CentOS. Basically, there's a file. You can specify in the file, hey, this is the pinned version in the second line of the file, 946 in this case. So the next time you do a apt-get update, Linux will update every other package but not touch that because that is pinned. So if you're holding out on an important kernel update just because you don't want your database to get restarted, there's a way out for that. Another tidbit, and this time it's AWS related, is so AWS CLI commands, especially commands like sync. Anybody uses those? Okay, yeah. So they are optimized for SSDs basically, and this one time I was using sync to transfer database backup from a magnetic drive on EC2 to S3, and it was extremely slow. And the network wasn't a bottleneck. It turned out to be the sync command because by default, the AWS CLI tool configuration has a concurrent request of 10, which is basically 10 parallel accesses to the disk at the same time. And yeah, for a magnetic disk drive, that was way too much. So make sure you change that if you have a magnetic drive. Same with the bandwidth. By default, bandwidth is none, so usually you shouldn't have a problem with that. But if it's set to something else and you're seeing that the network is a bottleneck and it's only a bottleneck for this AWS CLI command, you might want to check this parameter. Finally, the benchmarkings, the thing that you want to do to set each of those and not just follow the recommendations blindly. PG Bench is a great tool. Not many people might know this, but PG Bench allows for user-specified files for benchmarking. So like if, by default, if you run PG Bench, it's going to run its own set of reads and write query, right? But if you have very specific queries on your database, you know which queries are going to run more frequently, you can actually put them in a file, put them in a transaction block, and feed them to pgbench. You can feed pgbench multiple files, multiple transactions within multiple files, and it will take in all. And you can tell it how dispersed or how exactly to distribute it, how random it should make it, and the number of concurrent requests that it's making to the database. Do it for a long amount of time. Don't just do it for a minute per parameter change, because that's not going to be reliable. Your production is going to run for several months, hopefully several years, so make sure you at least run it for a couple of hours to a day or two, ideally. Make sure you only change one parameter at a time. If you're changing 2 or 3, obviously you're never going to be able to decipher which parameter it is that led to the performance increase or decrease. The best way is to automate that. So give it a certain set of parameters and certain set of values for each parameters, and let it run over the weekend for a specified amount of time for after each change. Finally, I wanted to touch this. So when to tune your Postgres cluster? Firstly, when you're setting up your new database, when you're migrating it to a new box, or you're going to a new major version of Postgres where new settings are added. And then the next most common thing is you notice a slow query or a query that previously performed well not performing that well, and then you look at your tuning and you try to see what's causing the problem. So essentially, the first 3 are kind of static tuning, and the second one is reactive. You're reacting to a problem. What can be next? What can be another type of tuning? So there can be on-demand tunings. There have been discussions where, let's say you're using PG benchmark or any background process that runs that is reading your log files or reading your system top or vmstat and processing those values, and it will come to know, oh, my system is under heavy load, I need to change certain parameters, and it can change those. So that's on-demand tuning. Predictive tuning is when you already have a lot of data about the system, about the database. You have a monitoring tool in place, so that has collected data worth of years worth. And so what you can do is feed it to ML algorithm, not blockchain, ML, and you can use that to kind of predict, let's say, on a Black Friday or when Christmas is approaching, and you don't want to let the system make the change itself. You want it to let the DBA or the developer know, because it can get scary really fast. But that's eventually, if that can be done well, that's going to be ideal. It's not too hard to, if you already have system data, the IO data, it's not too hard to feed it into a neural net. Get the values, get a graph out of it, see if you can find a pattern. So at the very least, you're going to know what to expect at a certain time of the year, a certain time of the day. Yeah, these 2, aside from the extensive information available online, these 2 are probably the most used. And that's it. Thank you. Any questions? Actually, I'm not too over time. It's 8:04.
No, you're fine. Yeah.
Let me know if you have any questions, and feel free to send me a feedback. Thank you.